Question here, we're asked what is the low frequency voltage gain for the amplifier shown. We're given some more information about here, but we're going to talk about how to solve this generally and then how to solve this specific problem, like always. So we have this problem here, and if we look at the notes linked below the like button on about page 141, we have our common collector amp, which is the emitter follower. Now, it doesn't look exactly the same, but they're both very similar. We can see our Q1 is different for both these, and our VO and everything is very different. However, if we are to take what we have here, or take what we have here, and we just rotate it along the horizontal axis, 90 degrees, it's going to look very similar. Now, this line right here, you can just think of it as VCC being right here, and our VI just being grounded, and our RC with the VCC right here going up. And so really, if we just reverse the circuit, it's going to look the exact same. Now, another way to check this is that our AV, so the gain that we are solving for, needs to be positive, but also less than 1. So that's another important thing to look at when you're solving for this problem. Now, we have this equation, and we're going to use it to find our voltage gain. That's what it's asking us for. There's a few things that we don't know. The first is our R pi. So let's solve for R pi. Now, for our pi, we've gone over this previously, and this was in this previous problem that we've done. We can really just copy the notes over the previous problem for other scenarios like this, but also not like this, and how to solve them can be found in the playlist linked below the like button in the description. But for this, we're going to use the following sets of equations that we have here to solve for it. Now, we've gone over this previously, so we're not going to go too much in depth with it here, but this is how we would solve for it. And our R pi is, if we simplify this down using these equations, plugging things in, we're going to get beta over GM. And our beta is going to be 34. Now, we don't know our GM, so we're going to need to solve for it. Well, GM, if we look at our equation here, and I'm not sure if it's listed here, but it is listed down here on page 142. So on page 142, still part of the same section, we have our I naught over VI. Now we need to rewrite this for our specific problem. Our specific problem asks us for IC over our VT. That's the information that it gives us. So we need to plug in these values, 698 times 10 to the negative 6 for micro, and then a 26 times 10 to the negative 3 for the milli. Now, if we do this, plugging everything into a calculator, we're going to get approximately 26.846 times 10 to the negative 3, or we could write this as milliamps. So that is going to be what we have here. So we're going to have 26.846 milliamps plugged in here. And then if we solve for this, we are going to get that our R pi is equal to approximately 1.2665, and this is in kilo ohms for our resistance. Now we're going to take this value, plug it back into our pi, plug in all of our values, and from here we should get that our AV is equal to approximately 0.923. We can see that that is a positive value, but it is also still less than 1, like our rule is right here. Now, if we wanted to solve for a resistance, like our R naught, we could use this following equation right here, as in the notes as well, where we just plug in our values here. We do a little bit of simplification, and we can solve for this. It says R naught is equal to 0, and that is because it's asking us to neglect the effects of bass width modulation. So with that in mind, we can solve for this if we wanted to. It's not part of our question, but it could be asked on like an exam or something. So going about this, this is from the notes, this exact equation is from the notes. These exact equations are from the notes, so you would just take everything here, you plug things in their respective places, and then we would need to solve for them. Now that would be like right here is what we would be using. So we would have our RE in parallel with whatever we get from this. So I would recommend solving for this first, our RB or RC or not, solve for this, then have it in parallel with our RE, and then we should be able to find our R naught here. And that is going to be the answer for this problem, and just a little bit of a side note as well.